Look at integrals resulting in inverse trig functions. So I have a little info thing here where we have the inverse functions, their domain, and then the reciprocal properties, right? Okay, so you can pause that and take a look at those. And then I also just put the integration rules here for a few of them. So if we have the integral of 1 over the square root of a squared minus u squared du, that's going to be our inverse sine. So inverse sine of u for a plus c. Then we have 1 over a squared plus u squared. It's going to be our tangent there. Or inverse tangent, I should say. So 1 over a, inverse tangent of u over a plus c. And then I have one here for inverse secant. All right. I don't know that I'm going to use that in today's examples, but it's there just in case. All right, I already see a little typo here. That should be 1 minus x squared, not x to the x. All right, so I want to evaluate this integral. So I have a square root here. So this is going to go with inverse sine. So I always write out what u and a are. So in this case, u is just x, and a is just 1, right? Because this is in the form a squared minus u squared. So we just take the square roots of those. So the square root of 1 is 1, and the square root of x squared is x, right? And then the one that has the variable, we might do a derivative. It might help us, it might not. It just depends. So my derivative here is going to be 1 dx. So that actually doesn't change anything. So now my integral is in the terms it needs to be in, so I can integrate it. So it's going to be inverse sine of u over a. And then we're going to evaluate it from 0 to 1/2. And so what I'll do is I just won't put the 1. So we have inverse sine of 1/2 minus inverse sine of 0. And the way I think about these inverse trig functions, yeah, we could plug it in a calculator and just make sure we're in the right mode. Usually I do these all in radians, I should say. So you could also think about it, think unit circle, and think, all right, where on the unit circle am I going to get an output of 1/2? Or where am I going to get an output of 0? And, in the unit circle, the x is cosine and the y is sine. So where do I get a sine of 0 and a sine of 1/2? So sine, getting a sine that's 1/2 is going to be pi over 6. And getting a sine of 0 is going to be at 0. So pi over 6 minus 0 is pi over 6. Okay. And all right, I have another one here that looks like it's in that inverse sine form. So u is the square root of 9x squared, which is going to be 3x. So du is going to be 3 dx. And I really only have 1, so I need to divide by 3. So 1/3. And then a is going to be the square root of 4, which is 2. So this is in the form of a squared minus u squared, right? So then I can go into the integral. So inverse sine of u over a. I don't have any bounds, so plus c. Right? Here's some more here. That looks like a inverse tangent here. U being the square root of 4x squared, which is going to be 2x. So du is 2 dx, which means I need to divide both sides by 2. And then a is just 1. So now it's in that form of a squared plus u squared du. So it's 1 over a inverse tangent of u over a, right, plus c. So I'll plug in my numbers. 1 over 1 is just 1. So inverse tangent, and then u, oh, I forgot my 1/2. U over a, u is 2x, a is 1, and then plus c. All right, then we can keep that idea here because I think that's another inverse tangent here. So u is going to be x, du is going to be 1 dx, so that doesn't do anything here, and a is 1. So I just need to evaluate it. So it's going to be inverse tangent of u over a, and then we'll evaluate it from root 3 over 3 to root 3. So inverse tangent of root 3 minus inverse tangent of root 3 over 3. So here's how I try to navigate this without a calculator, right? In the unit circle, the options of outputs, we have 0, 1, root 2 over 2, 1/2, and root 3 over 2. Right? These are all the options. We got positives and negatives in there throughout. Okay, so I want like what angle gives a result of root 3 and what angle gives a result of root 3 over 3. So those are combinations of the ones that have root 3 over 2. And those are always paired with some form of 1/2, right? So what I'm thinking here is usually tangent is sine over cosine, right? So y over x. And then inverse tangent is the reciprocal of that. So it's really x over y. And sorry, I paused it on my end. It's not a pause for you. So I forgot what I last said before I got distracted. So I know we're looking for an x over y scenario for these inverse tangent with these as a combination. So if the point is 1/2 and root 3 over 2, then x over y would be 1/2 divided by root 3 over 2, which would give us, let's see, big C over little c, so 2 over 2 root 3, which is really 1 over root 3, which is root 3 over 3. Okay, so that's this one. And then the other way would be if we had root 3 over 2 and 1/2. So that would give us root 3 over 2 divided by 1/2. Big C over little c here would be root 3 times 2 over 2, which is just root 3, right? So we would get pi over 3 minus pi over 6, which really we can make that what? 2 pi over 6 to get a final answer of pi over 6. I think, yeah, that is all I have for some inverse trig integrals here. So if you have any questions, let me know.